All right, guys. So we're back for the last video of this Fundamentals of EFI starter class, whatever you want to call it.
Yeah,
And
series.
this is our kind of more focus on the ECU side, which again, we're not going to be focusing on this too much more, but it's data logging, data log viewer, um, general tips on how to data log, when to have them enabled, because really at the end of the day, we are space limited. So one of the number one things people will go with is an aftermarket dash that has very large capacity storage unit. And then many of those have a USB drive. You can get a little stubby USB. I can actually pull one of these up that can have like half a terabyte and plug into the back of no, the plug. It was a very short,
Yeah,
stubby.
the ones that are this size. What are they?
They're
That size.
literally yeah.
Yeah.
So those can go in the back of your dash. And again, now that you have all this extra room, you can data log maybe instead of at uh 10 times per second, you can data log 100 times a second. And you could do instead of 10 channels, you could do 50 channels, right? Because now you have all this extra space. And you can set up things like I want these data logs to automatically delete themselves and then start new ones, or I can have um,
The infinite loop.
infinite loop. That's what I was going for. Thank you. Um,
It basically recycles. It drops the older part and then just adds new data as it comes in, and it just drops the oldest.
right.
But usually you have, depending on the memory size, I mean, anything beyond a megabyte or even 100 megabytes or 32 megabytes, what are they? It doesn't matter. It's a lot of data. This is just basically text.
Yeah. So
Yeah.
the main thing we're going to go over on this section of the video, this video is going to be understanding the data. And this is really pinpointing limitations, mechanical limitations, or fuel limitations, or ignition limitations, something that is telling us, hey, you should stop and identify a mechanical problem before you have a big problem. So the onboard stuff's cool. That means you don't need to have the laptop going. It's all integrated on the ECU. It's all integrated in your configuration for that.
Actually, we could probably mention a couple of the main differences based on the different brands that we've seen. For example, ECU number one, we can have, let's say, up to 80 channels internally, and then the max sample rate that you can do on this would probably be, I think, somewhere in the neighborhood of 200 times a second or 200 samples
2000.
per second. Well, no, this is brand one.
Oh, I got you. I got you.
Yeah, so I mean, anything that you can log at 10 hertz, 10 times a second, is probably very decent. Anything beyond 50 times a second is really awesome. 100, 200. Some systems these days are doing 1,000 times a second, which is radical and just gives you. You can even see engine compression on the crank sensor. It's ridiculous. So let's say brand B will have a much more refresh rate or much more sample rates, and it can absolutely log every single thing it's seeing or processing. So this is a very good option because then you don't have to worry about setting individual log blocks. Um, Pretty much all systems will let you also log to the laptop, and then depending on the system, there will be certain baud rates or speeds at which this can be done because of the transfer data of the setup. And then, of course, there are, as Ryan mentioned, external options to log, whether it is via the CAN, via another dash with a logging memory in it, or via some kind of a USB or little memory stick that can go in either the ECU, the dash, or a third device connected in the system. So what we're trying to do in this section is effectively give you a heads up. Data is important, and you can't just depend on what you see on the screen. You have to be able to go over it slowly, step by step, sensor by sensor, to be able to determine where the problem lies or if there's just anything that needs a little correction.
I'm looking here at USB
Yep.
flash memory rate for
Ah,
the ADU7. So what I'll do here is I'll pull this up.
okay.
So let's say, for instance, we have an aftermarket dash. We want to expand our logging capabilities. This dash will read at a maximum over the CAN bus of 500 hertz. That's 500 times per second for one channel. And you can have all your channels on that. Then you can use some
At that baud rate or at that refresh rate.
at that refresh rate. So it'll have all these specifics in regards to its overall logging capabilities. But what I wanted to show here was this little USB here. This thing is tiny. It is right there. Little
Yeah, yeah,
tiny, tiny dude. And
yeah. They're
this,
the size of a little Bluetooth dongle now.
right,
It's ridiculous.
512 gigabytes, so half a terabyte, and it costs you $47.
The size
Technology.
of your thumbnail. It's ridiculous.
Technology is ridiculous. But that will do something to where you have, this can now have pretty much unlimited data logging. This would be something if you're in a huge 24-hour race or off-road all the time or whatever the case may be, you're running all these channels. That could be something that's pretty cool to expand out to what you already have. So
You can never have too much data.
at least the important thing is that you get the correct data, your sensors are correct, and then
Yeah.
you understand what the sensors are telling you because the analysis is the important part,
Yeah.
right? So,
Yeah. So with that, I wanted to show a little log I have of a vehicle that I worked on for a little bit, and it ended up, the results after all was said and done and all the troubleshooting were what the owner effectively wanted. Um, but it just goes to show you that you have to have the information in order to know what's going on. So I'm going to put up here. Uh, Here we go. This is again our favorite ECU, the Amtron. um, Here, I'm going to just keep it simple. The
so
green line,
I'm going to cut you off. So
basically.
right now it's only showing half your screen. Go ahead and pull
Oh,
that up.
it's
Just
interesting. Is it? Because it's got the whole window. Huh.
yeah. So go to your screen sharing options.
Uh,
Should be
okay, that's
Zoom.
interesting.
So just click screen share again.
Yeah, I mean it was set to window.
Yeah, that's the problem is it cut it off in half you only had half of the display.
Okay.
That looks like
How
it's
about
good.
now?
That's perfect. We're good. Go ahead.
Okay, cool. All right. So we've got a whole bunch of stuff here, but what I want you to focus on is basically this green line. So as the RPMs start going up, which is the red line, we've got a bit of a dip in this green line. Now this is effectively running on one pump until this spot. And then we kicked on the second one. Now, if you notice, obviously we have a pressure drop that we didn't know we had before the secondary pump kicked on. So what we did here, we turned the secondary pump a little bit earlier in a later test. Having said that, what would happen is the green line would be nice, but eventually, once it got up to about 6,000 RPM, you can see the massive pressure drop all the way from around 69 psi down to a meager 48. And then if you look at boost pressure, we're already at 263 kPa, so it's about what 163.
So
It,
we
this is
lost
kPa
30.
absolute.
Well, if
Yeah,
you look
we lost about almost 20 plus psi of boost or pressure.
33 psi. If you look at the bottom left, you'll see bottom left, way down,
Yeah,
right here. So
yeah.
I actually have a
So
car like this, and one of
so
them is doing this thing where we have a pump and then it does not have a check valve into the section. So you've got a pump, and then the second pump goes to feed and it back feeds into the primary pump. And it does the
yep,
exact same thing that Claudio is showing right here. And
yep.
it comes down
So
to the use of a check valve in a multi-pump system is actually very important.
Yeah.
So,
One of the things that I've advised another customer, another situation is where they have the first pump on and they're getting the pressure drop itself. And then what happens is, depending on how it's plumbed, you will get pressure deviation back into where the pump is not working.
yep,
So this sort of thing is a bit detrimental, and of course, it's going to sabotage you in the long run. Um,
always use
fuel
check valves.
Yeah, fuel sizing is important. Fuel system sizing is important. Hose, running of your lines. All this is key because you got to think of the flow of the fluid and what the pressure does. As soon as the pressure starts to come up in the system, then of course fluid is going to take the path of least resistance to where it needs to.
Let's open that one back up real quick. I want to go over a few more things because we have so much good information on this log.
Yeah.
This is a
Well,
fantastic log you put together.
let's see if this thing wants to work.
Yeah, when it did the full
There we
screen,
go.
okay,
Is it
that'll
there?
work. It will be. Okay.
Okay.
So
What do you want me?
right now we can look at our lambda in our violet or whatever purplish color, and you can see
Yeah,
it's
this
kind of
part right
oscillating.
here.
It's moving up and down, moving up and down.
Yes,
But let's see how
you can
big
see
that
it here too.
oscillation is. No, let's go just to the standardized waving right here between this time and here, like this section.
Yeah, I don't see what you're doing. You got to tell me where in the box.
Go from 0 seconds to 3 seconds on,
Like here.
yeah, we're just trying to trace slowly and see how big that oscillation is and that
Oh,
initial
okay.
before the log.
Okay, right there.
So I just want to show you guys the peak here is like 0.853, right?
Mm-hmm.
You go down to the basins to see where that's at.
Yeah.
Okay. So our
If you
oscillation, even though it
point
looks
seven.
really big on this log, the reason why I'm bringing this up is it really isn't that huge of an oscillation, but it is something to look into.
Yeah.
And you can see why it's tracing, or while it's tracing through the short term, like that's pulling 14% fuel out, it's getting rich, and then it's going to go back and it's pulling 8% out. So what's probably happening here? Do we see differential pressure? It's
It's
8%
it's
change.
down on the left
Yeah,
side,
yeah. So
black and
there's
red, white and red.
8% change there. So what's very likely happening is I don't think this is a fuel dampening issue as far as like on the rail with a fuel pressure damper. This is
Mm-hmm.
most likely as simple as the PID control for the Lambda controller is a
It
little
is
bit too
possible.
aggressive.
It is
That's most
possible.
likely.
Yeah, it is possible for sure.
It's
Yeah,
yep.
eventually, this is like probably 2 years, well over a year ago. So this has gone through a little bit more polishing after this. The pumps were switched out. That eliminated the fuel pressure drop. So
I
that
was
that
gonna
car
say
eventually made 1,057 horsepower at 50 pounds of boost.
that's
Yeah.
amazing.
On E85, on Ford ID 2600 injectors, and the car is a rocket.
All I was saying on that was we
Yeah.
have so much data in this that you can go through each one of those tabs and say like, okay, chassis control is demanding this. We've got different, I mean, because we can go back and show them on the tab for the logging software. That's what I was trying to get to,
Mm-hmm.
is show them all these different channels that can be logged and the versatility of setting things up to your understanding of analysis. So when he brings that back
Oh,
up, I'll kind of go through that
yeah. Yeah. Here we go. All right.
because we don't have to go through how
All
to
right. So
change all this stuff, but let's show them what.
So, for example, yeah, I mean, effectively, there is a boatload of default layouts that you can actually just scroll through without even needing to create any of your own logs. So, essentially, the Mtron software has a lot of information, has a lot of setup, has a lot of just user functionality built into the base
I
templates or the base maps that it's just ridiculous.
it's ridiculous. And then go to the group to the very top, and you could see that it goes for more than just the engine.
Exactly. Then you've got diagnostics, which just changes all the layouts again, and it gives you a bunch more stuff. And there's histograms, and it just, I mean, my laptop's actually dying right now, so I'm just going to go back to the original one. So
So
effectively, we start with this humble little page that I've got here. You've got a whole bunch of stuff that flickering all the time, and the ECU is logging all the time. So that's what makes this fantastic.
yeah.
So you do a run, you start the logger, and it just goes through everything. So you've got your the ability to set up your channels on one graph, on another graph. So that'll give you groupings of individual data that is related to itself in some way, shape, or form. But again, scroll through everything, and you have as much as you can possibly need.
What's really
You want
cool,
to
go to the boost one real quick. And
boost.
so as per our last PID
So
video,
just to
there
reiterate,
is
this is built into the base map. This is
yeah,
what what
this
if
is
you
what they
open up
supply.
one, it's what's already in there. So this is
Yeah.
already done for me. I didn't have to do that. You can. I mean, you can just right click here and set up your graphs and do whatever you want. But obviously, what you want to see here?
So this is incredible the way that you can look out and see, do I have too much proportional, integral, or derivative? You can plot everything turbo speed and then comparing things to a compressor map. You have the valve position on the far left. You have the actual tracing for RPM, boost pressure, targeting. And then this is where it could add in stuff like torque modeling. So your torque model might say, I want this demand. We can give you this much boost, and then it modulates the boost to get that torque. This goes in so far in depth for the logging, and it's just the software is amazing.
Yeah, I
This is
mean, a
something
lot
that's
of
just amazing.
in this yeah in this particular scenario. I mean, we don't have a lot of stuff on this particular card that would have made this more useful. That's why I kind of stuck to the tune one, which I have is basically just what I need. But yeah, I mean, you
Yeah.
can put stuff on here till your heart's content and analyze this till you're blue in the face. Of course, every system will have a more advanced or more simpler data logging scenario. It's up to you to make use of it. Don't think of it as too simplified. Try to put it to work and log your RPMs, log your pressures, your sensors, and everything. Then you should be able to at least make heads or tails of what's going on and how to improve it.
So one thing that's really good with this, and I was going to show Fuel Tech does something kind of similar, but a simplified version, is you can have any of this as you're going through it, and then you click, is it Q? One of the buttons will go back to the original, let's say you're doing fuel or boost control or something on your tune file, and it will have a quick back and forth between your logging and your tune file. And it will go through and say, like, let's say we're looking at our boost duty, it can quickly go back and forth between them, and then you're adding in the changes that it's requesting, and then the changes for what it actually needs. It ends up making all of
How
our
Haltech does something a little similar, which is if you load the log to view in the software, you are able to navigate the log and also get the tables to respond to the log so that you can go in and see exactly what was logged and where you at, so you can make changes at that precise point, and you can go back and forth. Then you can fix your map to what you need. Let's say, for example, your log told you that you were 0.80 lambda, but you needed to be at 0.83 in this cell. You make that quick change, save it, you know, switch out of the log, and then put that change real quick and move on.
I'm gonna pull up here. Let's
You
see.
got one to see?
Yeah, I think so. Let's just double check I even have it on the computer. I might not. All these millions of files, but the thing is that I don't normally back up data logs because there are so many of those that just absurd. So
Yeah.
I do
I usually will name the key one that I always want to go back to
Mhm.
differently than the default name. Yeah. A little
Yeah,
hot tip there. If you have a log that you always want to keep the task, let's say that was the moon tune or the ballistic mode, whatnot. Just give it a new name so that way you can find it, even if you don't keep the other ones.
I'll be right back. I'm going to change another camera battery.
Oh Lord!
All right, so we're back.
All right,
Only two batteries down.
put
So
them on the charger.
I've got six. That's why. So um, the other notes we really have are, you know, laptop, we're always going to have this unlimited data. We can do everything we want. For the on ECU, it's going to be based on the ECU, what you really want to choose. I normally set something to where instead of having like a throttle position, which would probably trigger a lot because I rev cars and I'm kind of a jackass, I would do something like a boosted application. I would do it off boost pressure. Um, for nitrous application, I do it when nitrous is turned on, stuff like that. So
You mean the automatic
your
is start of the
your
log?
auto enable for your logging to start the log. And then I also select a duration after the event is over in which it continues recording.
Yeah.
So let's say, for instance, we have a wide open throttle pull and it's auto logging to the ECU every time. So when it goes through, let's say it passes through 4 psi of boost, it kicks on. When it goes into that 4 psi boost, it goes through, let's say, a run up to 150 miles an hour. And after 150 miles an hour, you let off, it stops the log because now you've gone below that threshold of 4 psi. Then I give it a duration of maybe 3 to 10 to 30 seconds to really depending on what the capacity is for the ECU. And then that can be an infinite loop. So obviously, if nothing happened, I'm not going to have to look at the logs. If something feels like, okay, we're getting a fuel pressure drop, we're getting a spark plug that's starting to foul, we're getting whatever the scenario is, um, I go through logs. I can identify the problem almost instantaneously. Um, we did not talk about individual ECUs with their DTCs or check engine lights, and we can probably add that into this section because logging, really the reason why we're doing this is we want to have the ECU telling us why we have certain faults, and then what do we do to fix these? Well, everything is going to have a different approach to fix the solution. There's hundreds of them when it comes to things that will stop an engine in its tracks, hit an engine protection, and it's our job to kind of make sure that the vehicles can stay reliable. So go for it, Claudia.
Yeah, I mean, when I usually try to do RPM, I like a 2000 RPM threshold. That way I can get some nice cruising data sometimes when people just go off on the road. And then obviously you said 3 or 4 seconds of delay time so that the log shuts off after they come down. And then of course, when you pull the log, you'll see a bunch of sections of the log and then nothing below that, which is nice, saves data because you don't want the car at a stoplight idling and then wasting data log space or effectively running your data, your good data off the log. And
Good
then when
point.
it comes to the individual ECUs like check DTCs, this can also harken back to the necessity of engine protection, which you can view through the log. What tripped if a sensor went out of spec or something happened that caused the trouble, then it's sensor related. Because you could have, let's say, a coolant temp sensor go off, disconnect, break, melt, whatever. And then that will force the ECU into a different territory of the map. It's going to think it's 2 lane, or you can tell the ECU if the reading of the sensor goes beyond a specific point, say sensor disconnected or shorted, then of course that will just put it into a specific spot and not sort of make the tune go out of spec, either be too rich or too lean.
Yeah. And then I think the last thing we really need to cover is math channels. So individual stuff like we talked about in the last
Yeah.
video, and we got a little bit
Yep.
more complicated. Um, Going through and creating your own conditions or creating your own channels to where you can work off of axes could be anything.
Yep.
So
Now, some ECUs will have math channels available within the tune. Some ECUs will only allow you to do math channels in a log. And this is just to have some extra data, extra numbers or channels that you don't have built in by the ECU manufacturer at the time you're checking. Obviously, these are requests that can be sent over, but most of the time, the ECU either does it or it doesn't.
one that always comes to mind that I think of math channels is if we go over like Andy Whittle has a really good write-up on Megalog Viewer and his math channels that he's using for log analysis. He can have plot versus plot versus plot times this divided by this, doing other certain things as a comparison. And what it's trying to do is instead of having these random dots of information that skew your accurate numbers, it's doing a filtration. And so a math channel can be used to filter and better clean up the actual reality of what the vehicle is doing. Now, again, this is not tuning. This is just, we're talking about software analysis at this point. We're not talking about identifying what the engine needs. That's a completely different subject. This is
You could say is basically determining what the engine is doing,
correct.
not what you need it to do.
What you need it to do and what it's doing are two different things. Tuning is a little bit too broadly thrown around. So we can definitely get into that with the advanced video series. That's not going to be covered this time around, but math channels can be all sorts of things that will identify and eliminate the noise of the system and therefore giving you corrected data to work off of.
Yeah, I can remember a time when we didn't have the target AFR error, which is basically by how much AFR are you off, and then we just go into the data log viewer and then just create a little math between a couple of things, and then you had that. But now you have it, so now you don't need it.
We are spoiled. We are very spoiled with all the
Well, it's
options.
good that manufacturers listen to people and say, "What do you need?" Well, here you go. That's also great. Reception from the manufacturers is always fantastic. Helps the system grow. It helps the cars run better, and basically gives the people what they want.
With every industry, competition is always a great thing. It will push us all to do better. And the only one who does any sort of complaining about competition is the ones that aren't putting in the effort. So they're usually very easy to spot, and you just gotta put your work in and you'll get the results you're after.
Yeah. So that's why you log. You want the results.
That's it.
All right. I think we can call it a day for this one.
Yeah.
Hopefully we can continue with the advanced ones soon enough, and then maybe we can do a live.
I think we can do a live.
Ask questions. Yeah.
That would be good. So we'll just recap real quick. This was purely fundamentals of configuring an ECU, fundamentals of wiring, and I don't know, what else would you call this, Claudio? This is
Well, I mean, it's what you need to know and do to get started. It's a little help, a little nudge into, okay, pick the system of your choice. Get one that you can feel comfortable with. Get one that you have good support with the manufacturer from. Get one that's popular and a lot of people can chime in if you need help and can't get a hold of the manufacturer. And get one that is going to do the job that you need it to. A lot of people say, I only have $1,000 for an ECU. Okay, what's the engine? A V8 twin turbo LS. You're not going to get an ECU for a V8 twin turbo LS for $1,000. If you do, it won't do what you need it to do. So think thoroughly. Remember, an ECU will do the job of making your very expensive engine run great and not break it.
So one thing that actually Claudia brought up perfectly, um, just like we don't have a drag racing tuner go calibrate a car that's designed to be daily driven on the street because they don't require the same things. You're going to have ECUs are going to be operating in niches of their market. So some will have feature sets that are designed to be better for certain applications. Some are going to be more an OEM plus, like a Honda board that's integrated on a factory ECU, or a Power FC that's integrated on a factory ECU side of things. That is a sister or daughter board, whatever you call it, on top of a factory ECU operating alongside it and manipulating those values. And when you shop for budget, that should only be part of the equation, right? These are the tool, they're only good as the tools, I guess, in your I am so hungover. So
I guess the point you're trying to make is if you want to go cheap, you're going to get something that's overly simple that won't do a lot. I mean, you'll be able to put fuel in it, you'll be able to control timing, but that's about it.
when you
And
go
then if you
cheap,
want to,
it's really expensive.
yeah, exactly. And then of course, if it doesn't have good engine protection strategies, if it doesn't have good diagnostic strategies, you end up using something that effectively is just like a carburetor with an ignition, with a mechanical ignition. You have no control over
Which there's
it. It's
nothing
got
wrong
no
with that.
safety. Yeah,
Right.
but it's got no safeties, and your engine's a lot more expensive than that. It deserves better.
Yeah.
All
Well,
right.
I think that does just about does it. The next video series, I will have a lot more energy, I promise, and a little more input for you guys. But I think we did a pretty good job covering just about everything for getting you guys started. Please let us know. I know a few of you have already reached out with a bunch of amazing notes. Really appreciate it. Please
Yep.
let us know what you'd like to see in the next series because we have a few options we're kind of weighing right now. Whether we go more right into the advanced stuff, whether we talk about how an engine actually operates, which I think is going to be kind of the pinnacle of all of these series.
Yep.
And then that means it's not just tuning, it's more so what is an engine? That's a very, very uh large bite for someone to consume. It's just a big subject.
And it has
Um,
to be. It has to be done
it
in
has to be
sections.
digested.
Yeah, it has to be done in small bites because definitely an engine is a very complex machine. It has a lot of moving parts, and each moving part has its own functionality and control.
Yeah.
All
So
right.
just give us some input. We're going to try to make the next video series right about the same price, right about the same length with maybe 8 or 9 videos. And we're really going to focus on improving the quality of this output so that you guys feel like you've learned more than where you have in the past for other sources. So give us some feedback, drop us some emails, like, subscribe. I don't know, whatever YouTube people do these days. Who cares?
Yeah, you check the description below.
Yeah,
That's how you say
who
it.
cares? We'll try to help you guys as best we can, and always reach out if you need us directly. Tuning Technology, Right Brain Design, and yeah, we'll get you guys taken care of. So we'll catch you next
Have a
one.
good weekend, everybody.
Yeah. Cheers, y'all. See ya.